as well as testosterone. And what I want to point out to you is how similar estradiol and testosterone are. But there's a great big difference between male and female, right? Did you know that it boiled down to a methyl here and a hydroxyl here versus a carbonyl? That's all. How about that? Isn't that amazing? Okay. All right. What you're looking at here is a compound called bisphenol A. This is its structure. Bisphenol A is a very controversial compound. Well, I should call it a molecule. Bisphenol A is a very controversial molecule because the chemical industry uses it for lining a lot of packaging materials. It's also it's also found in plastic bottles, including baby bottles. What's unfortunate about bisphenol A is by virtue of its structure, these two methyls, these two hydroxyls, and these ring structures, by virtue of its structure, it becomes what is called an endocrine disruptor. It has the ability, by virtue of its structure, to bind to an estrogen receptor as well as the testosterone receptor. And so it interferes with the normal biological pathways that use estrogen and testosterone. Like I said, this is a major, major controversy as we speak because, of course, the chemical industry is saying, no, this can't be. But unfortunately, all of the testing on bisphenol A says, yes, it is. So stay tuned. But nonetheless, what I'm pointing out to you is by virtue of this structure right here, really allows for bisphenol A to act like estrogen. So you can see some overlap in the structure. When you see an overlap in the structure, that would certainly give you a warning that there could be some cross interaction. And I don't know how, I'm not sure if it's fully known how bisphenol A interferes with the testosterone pathway. You can certainly see how it could with estrogen, right? You can see the overlap in structure. Testosterone is not entirely clear to me. It could very well be the combination of the methyl and the ring structure that allows it to interact with the testosterone receptor, but it's not so obvious. Any questions? Questions? All right, so let's talk about these various functional groups that lend chemical reactivity to biological molecules. We've already been introduced to hydroxyl, which is an oxygen covalently bonded to hydrogen, and the oxygen, usually on a biological molecule, the oxygen is usually covalently bonded to carbon, and it actually forms one of our favorite molecules on Earth, and that would be ethanol. Okay? Any kind of biological molecule with a hydroxyl qualifies as an alcohol. Alcohols, usually you can tell it's an alcohol because its name ends in OL. What I want to point out is the polarity of this covalent bond here. Oxygen is so polar that what it will do is it will draw electrons towards itself. It will draw electrons towards itself. What's interesting also, because of the polarity of oxygen and how it pulls electrons towards itself, the hydrogen of an alcohol group doesn't usually ionize. And we'll talk about ionization